Second video for chapter 10, still looking at section 1, linear equations and solving those linear equations, finding out the value of x that makes it work. We looked at the balance method doing algebraically in the first video. This one looks at using a graph. You need to do this stuff before you can do chapter 14, which looks at linear and quadratic graphs in a lot more detail. So you will get to understand these even further once you've done that chapter 14. So the other reason, that's my first so you can start the tally now. The other reason that we call it linear is because when you draw a graph for them, you get a straight line. Linear, straight line. Going to look at drawing those graphs and then using those graphs to actually solve it. If we're looking at this point, 0, 3, that tells me when x is 0. Remember, this is the x-axis because it's across. X is across. I like that. This is the y-axis. And I just sort of say, well, why not? Anyway, when we're looking at x is 0, that point there, we can see y is equal to 3. So the x value is 0, y value 3 gives me that coordinate there. If we were writing it as a coordinate, it would be the x value and then the y value. X value and y value. I'll be doing one of these on paper, I hope. I can find an assistant camera person to help me with that. But for now, we'll just look at what's on the screen. First thing to do is to actually work out all the values that are going to be on the graph. The question will normally tell you to work out the values of y for x equals minus 3 to plus 3. Or it might say for x is 0 to plus 5. But you'll be given the values of x it wants you to use, and you just put those into the equation. So you put minus 3 into this equation. 2 lots of minus 3 is minus 6. Add 3 to that, gives you the answer minus 3. If we're looking at when x is minus 2, 2 lots of minus 2 is minus 4. Add on 3, minus 1. This one, we put in minus 1. 2 lots of minus 1, minus 2. Add on 3, plus 1. We can see, which we'll see in more detail when we look at chapter 4, that this is going up by 2. It goes up by 2 because that is a 2 there. Also, when you've got the x value as 0, then the y value is just a number there, 3, which I looked at earlier. So again, that will come up in more detail in chapter 14 about why those connections work. But it's useful for actually working these all out and checking that you have got the correct answers. You can see them there. This is the sort of question you might get. And sometimes you'll be given the graph and asked to read off it. Sometimes you'll be asked to draw the graph. Using this graph of y equals minus 5 minus 2x. Now, because it's a minus 2x, a minus value there, the graph actually goes that way. In the previous one, when it was a plus x, the graph went that way. But minus x makes it go there. Minus 5. So when x is 0, that will be nothing. So we'll only have minus 5. So if we look at 0, x is 0, there's y is minus 5. Anyway, to solve these equations, so when that equation there, the one I had there, same equation, is equal to 12. So where is 12? 12 is up here. That's 10, 11, 12. So I go across, and there's my value when it's 12. So I need to come down and find out that the x value, I'm making that minus 8. And this is a drawback of doing it by graphs. You can't be completely accurate. Obviously, the bigger the scale, the bigger the graph, the more accurate you can be. This again in B, I've got that same equation, that equation there, and I want it to be equal to minus 4. So y is minus 4. So when is it minus 4? Minus 4 is this line here. So minus 4 I would have said that looks about x is equal to -1 for that one. Finally, I've got this one again. So when is it equal to 4? When is y equal to 4? There's 5, so there's 4. That's where 4 is. I'd probably say that looks about minus 4.5. That value there is in between those two lines. This one, doesn't matter they've written it around the other way, we're still looking for the equation, that graph. Where is it? 11. 11 is up here. So again, come across, I can read it off down to there. That looks to be about -8. This one now is asking you to actually draw it, and you've got to use the axes from 0 to 10. So you do your table and actually do that from 0 to 10 for all those x values, work out what y is. You then use it in the same way to solve those. Written out an example question to show you the process of drawing a graph in case some of you need a hand with that. So we've got draw a graph of y equals 3x minus 4 from x equals -2 to 4. Find the value of x that gives those two solutions there, which I'll read off from the graph once I've plotted it. So the first step is going to be to actually work out the values of the coordinates on the graph. Brings back many happy memories of math lessons at school. I spent years doing these, so should be okay here. Here's the values of x that I need. I'm going to put those into the equation, which was 3x minus 4. So when it's -2, 3 lots of that is -6. Take away another 4 will give me -10. 3 lots of that x, 3 lots of -1 is -3. Take away the 4 again, -7. 3 lots of nothing is nothing. Take away 4 will give me -4. Just to remind you, we said before that when x is nothing, the only bit of the equation you have is that. So that tells you where it goes through the y-axis. Anyway, back to here. When x is 1, 3 lots of 1 is 3. Take away 4, -1. 3 lots of 2 is 6. Take away 4 is 2. 3 lots of 3 is 9. Take away 4 is 5. 3 lots of 4 is 12. Take away 4 is 8. And again, you see these go up by 3. Because I go back to the equation, I had 3x. So now I've got my coordinates. So this coordinate is 0, -4. This coordinate is 2, 2. I won't say that's where I wear the weekends. It's a terrible old joke. But now I can actually draw the graph. So I've drawn out the axes. You should always work out the values before you draw the axes. If you've got an exam paper, they will have a grid drawn out already, but sometimes they will still expect you to put the numbers on. You need to go back and look at the biggest and smallest values. So I've got a difference of 18. So on here, I've got to make sure I can go from that difference of 18, I can go from +8 to -10. And I've got to make sure I can go from -2 to +4. The bigger the scale you can put on there, the more accurate you can read off your answers when you're looking for those solutions. My maths teacher wouldn't be happy that I've done this in pen. Should always do it in pencil. Sorry, Mr. Watson. But anyway, let's plot the points. So when x was 0, I had y was equal to 4. Remember those points I worked out from that table. So I'm going to read those off. When x was 0, I had -4. When x was 1, I had -1. When it was 2, I had a value of 2. 3, I had a value of 5. And 4, I had a value of 8. The negative ones, when it was -1, I had a value of -7. Down here. and when it was minus 2 I had a value of minus 10, my lowest point there. Now if you look at that, you get a nice straight line which tells you you've done it right. Here's a straight line drawn. There's a smudge on there, I do apologise, that's why you should always do it in pencil. Anyway, I now need to answer those questions, and it asked me 7 equals 3x minus 4. So I'm looking for the value of 7. 7 is up here. So there's my value of 7. I've got to go across to the line and it hits it here. So now I need to get the ruler and draw a straight line down here as accurately as possible. Paused it there because I've only got 2 hands to draw the line down from the point where it was 7. And you can see I've got a value of what I would estimate at around 3.6. So the answer for that one, when y was 7, I had an answer of x equals 3.6. That's my approximate answer, which again is what I said with the drawback of the graphs. The other one was to work out when it was equal to minus 2. So now I need to look at the value for y is minus 2. That's there. So again, I come across to this point here. Again, I pause so I can actually draw the line with a ruler, try and be as accurate as possible. But we came across from minus 2 to that point there and then straight up. Terrible smudges, because you should be using that pencil. But anyway, we've come up from that point there and we've got an approximate answer for around, I'd estimate, 0.7. Again, the drawback of doing a graph is it's not precise. But hopefully that's given you a fairly good indication of the techniques and the methods to actually do it on a graph. Remember, use a pencil. If you're doing the exam, you might want to go over it in pen after to make sure it's readable by the examiner, but do your first piece of work in pencil in case you make a mistake. You can always change it. These are sort of questions you'd get in 10.1a in the application section. Rather than just giving you a linear equation to solve, they put it in the form of this. So the perimeter of this shape is 30 meters. Work out the length of each side. So if the perimeter is going to be this side and this side, and this side and this side. So all of these. Remember that that side there is the same as that side there. So I've got 2 lots of this and I've got 2 lots of this. So in total, I'll have 4x plus 12 and 10 take away 2x. So when I put all those together, the 4x plus 12 and the 10 minus 2x, I'll have a total of 2x plus 22. And that it's told me is equal to 30. So then, using my linear equation, I can work out that I must have 2x equal to 8. Opposite of multiply by 2, divide by 2, so x is equal to 4. So that's using the skills I had from the first video, applying to this question. The diagram shows an isosceles triangle. The equal angles are 10 degrees less than the double the third angle. For question 9, we need to know that these two opposite sides are equal. So 7x minus 9 is equal to that bracket multiplied out, which is going to be 5 times 7, 35, and 5 times minus 3x minus 15x. You've then got a linear equation with x's on both sides that you solve in the normal way. Number 10, if I take my age now as being x, in 10 years' time, I'll be x plus 10. 11 years ago, I was x take away 11. And it tells me that my age in 10 years' time will be double 2 lots of what it was 11 years ago. Multiply out that bracket, it all comes out, and it gives you an answer of 32, which is something I can only dream of. Anyway, that's just a few of the application questions you'll see in exercise A. Good luck with those. My next video will be where I start to look at the quadratic methods. Good luck. Take care. Bye bye.